Hello everyone. In this lecture, we are going to study about the solution of 1D wave equation by using separation of variable method and some of the important equations related to it. Now, some of the important equation in this unit are: first is 1D wave equation, also known as string equation. A string meaning if we tie a rope between 2 points A and B, or we tie a wire between A and B, or rubber band between A and B, and if we stretch till any point C and release it, then there is a vibration between the system. This system is called a string, and this system mathematically represented by del square u by del t square is equal to c square del square u by del x square, where c square is a constant depending upon the material of the model. Second is 1D heat equation represented by del square u by del t. Del u by del t is equal to c square del square u by del x square. Again, the c square is depending upon the material of the model. And this is the 1D heat equation. If we consider a rod or a iron bar, then if we give a heat to a particular point A, and then heat will be transferred from A towards B, then calculation of the heat transfer or particular point temperature is based on this equation. Now, 2D heat equation or a Laplace equation or steady state. If u is independent of time, that means with respect to time there is no change in u, and u is the function which is representing the temperature, then del u by del t is equal to 0. That means with respect to time there is no change in temperature. That means at the steady state. Then this equation of 2D heat equation or 2D Laplace equation is represented as del square u by del x square plus del square u by del y square. It is also equal to del square, this is the vector operator, del square of u x y. This is for 2D. If we are going to study for the 3D, then the equation will be del square u of x, y and z. Third dimension is also added over there. Now 2D heat equation in which del u by del t is not equal to 0, then this equation will be equal to del u by del t is equal to c square del square u by del x square plus del square u by del y square, and again c square is depending upon the quality or property of the model material. Now, solution of 1D wave equation or string. To solve this, the equation is del square u by del t square is equal to c square del square by del x square. This is the 1D wave equation. You have to remember this equation. Now, because u is depending upon t and x, then we assume that the solution of u is equal to x and t, x into t, where capital X is a function of small x and capital T is a function of small t. Now, if this is the solution, then this solution must satisfy the given equation. Now we substitute this solution in the given problem. So first we have to differentiate with respect to t twice and with respect to x twice. We get equation 2 and 3. Substituting this equation 2, 3 and 1 in equation in a given problem of string equation, we get del square d square t by dt square x is equal to c square d square x by dx square t. Now separating the variable, we divide this equation by xt. The variable is separate, t is with variable of t derivative and x is along with the derivative of x. Now the variable is separate, we have to assume this is equal to a constant as minus p square. why we assume this as a minus of p square not equal to k? If we assume it as equal to k, then the value of k will be either negative or positive or equal to 0. But if we are asking or if we are discussing about the string, that means whenever we start the vibration between point A and B with the tightly stretched string, this vibration will be always try to be at rest. So the steady state for this string is always be at rest. Whenever we stretch this string at particular point T or at particular point D, then next time this string will not reach at this point. It will be less than this point and again the less than this point, and after a few times this string will be at rest. That means the vibration is decreasing, that displacement is decreasing. So we always consider the coefficient as a negative value. So when consider the k as a negative, it is better to consider minus of p square, whether the p is positive or negative. If we do find out the value of p square, it is always positive value, and if we use minus of p square, this always gives you a negative value. So after separating the variable, we assume this is equal to minus of p square. Why we are taking the minus? Because the displacement is always decreasing. It is having the decrement in the displacement. So we show that decrement with the negative sign. Now for heat wave or 2D heat equation, we will always take P as a negative because heat is also decreasing with respect to time. Vibration is also decreasing with respect to time. There is no physical model in the universe which is going to be increasing, that is, which is going to be unstable. It is not possible that the vibration at first time is over here and without the external force this vibration will reach to the next new point. It is not possible. So we are always taking it is decreasing. Now for solving 1 by t square t by dt square is equal to minus of p square. By solving this equation, we have the auxiliary equation as m square plus p square is equal to 0. So the CF or the value of t is equal to C1 cos pt plus C2 sin pt. Now we solve for the second value, c square d square x by dx square 1 by x is equal to p square. The auxiliary equation for this problem is m square plus p square by c square is equal to 0. That means m is equal to plus minus p by c iota. So the capital X is equal to C3 cos p by c x plus C4 sin p by c x. So we get the value of x and t. So finally the solution by using the equation A and B, we get the solution of x into the solution of t. This equation should be remembered by you because in the next question or the question of the string we will directly use this equation. If we take constant c square in equation 6 with variable t, then the solution will be this. Both the solution are correct. Both the solution are correct because c square is the constant. When we separate the variable, we can take c square along with t or x. If we take c square along with x, we get this type of solution. And if we take c square along with the variable t, then the solution is this. Both the solution are right, but I used to prefer this solution in the problems. Now this is the general solution for the vibrating string, and this is represented as this. Condition for string. There are few boundary conditions. This is the representation of the string. If we tightly stretch the string between the point A and B and give a displacement from a point D, then the system will start vibrating. This vibrating system is called a string, and because it is in a two dimension, this is x and this is represented as u as per the equation. Displacement is represented by the u. If we consider this, then this a point is considered as a 0 and this point B is considered as a L because the dimension is in the form of direction of x, and this is u. If the length of the string is L and it is fixed from the both point A and B, and let we take u xt as a function of displacement. U is depending upon the x and the time. U is depending upon x and time. Then the starting point A displacement will be 0 because it is fixed. Whenever we vibrate the string, point A is always having a displacement in the direction of u, either in a positive or negative, is 0. So at the boundary starting point u a t is always 0. It is not affected by any condition until unless it is released from here or it is broken. So whenever the point A is fixed, the displacement at point A is 0. Similarly, the displacement at point B is 0 because B point is also fixed. Now, if a string is at rest, not vibrating, then at the time 0, rate of change in the displacement function with respect to time is, that means when the string is at rest, that means there is no vibration, then del u by del t, that means rate of change in the displacement with respect to time is 0. There is no rate of change, there is no displacement and decrement in the displacement with respect to time at t is equal to 0. So these are the conditions which you have to remember in the question related to the string, as well as it is also required to remember the equation of the string. Now we will consider one example, a string of length L whose ends are fixed at a point A and B. At initial time it is at rest. Find its displacement function. Let the displacement function of the string is uxt and the equation is del square u by del t square is equal to c square del square u by del x square. From the previous solution, we just use the general solution of the string is uxt is equal to c1 cos px plus c2 sin px into c3 cos cpt plus c4 sin cpt as a general solution. This is the first solution till now. Now for this question, the condition is u a when the starting point u is equal to 0 when the starting point is fixed, and u at the ending point is 0 because it is fixed at point A as well as point B. For point A the condition is this, for point B the condition is this, and rate of change in u with respect to time is 0 because at initial time it is at rest. So at initial time means when t is 0 and del u by del t is equal to 0. Now substituting the first value, that at point t when x is 0 in equation G, when x is 0 we get the value u0t is equal to c1 cos c2 into 0 c3 cos cpt plus c4 sin cpt. Now the term we can say that x into or k into, or we can say that m into n is equal to 0. That means either m is equal to 0 or n is equal to 0 or m and n both is equal to 0. Now over here we have C1 into the complete term. You have to always remember this term is not changed with respect to the general solution. In our general solution, this term is exactly same. So if we consider this term as a 0, if we consider this term as 0 and we substitute this value in G, the solution will be 0. So solution is never 0 in these types of the problem. So we will have C1 is equal to 0. We have C1 is equal to 0. Now instead of this m or n, I am again explaining it that k into r is equal to 0. Either k is 0 or r is 0 or k or r both are 0. But over here this term is never equal to 0. If this is 0 then solution will be 0. So C1 is equal to 0. We will have C1 is equal to 0. Substitute this C1 in your general solution. Now the next solution, next level solution, this is your updated solution. The updated solution will be uxt is equal to C2 sin px C3 cos cpt plus C4 sin cpt. Now remember the C1 is 0. Because the C1 is 0, so this term will be eliminated. Now we have new solution. This is represented as G1. Now we have to substitute the next condition. The next condition is at point B, that is ULT when x is equal to L, when x is equal to capital L is equal to 0. Now we substitute the value C2 sin PL and C3 cos CPT plus C4 sin CPT. Again this value is not changed, so this is not equal to 0. We have either C2 is equal to 0 or sin CPL is equal to 0. So we have the product of the three values. One is C2, second is sin PL, and third is this. We know that third value is not equal to 0. Either C2 is 0 or sin PL is 0. If C2 is 0, then complete solution will be 0 because 0 is multiplied with complete solution. If C2 is 0, then our solution will be 0, which is not possible. So if we take this value as a 0, the solution will be again 0. So we have only one option, sin PL is equal to 0. Because sin PL is equal to 0, sin theta is always 0 when sin n pi. That means when the angle is n pi, it is equal to 0. Now we are comparing sin PL is equal to sin n pi. So finally we have the angle comparison between PL is equal to n pi and P is equal to n pi by L. P is also arbitrary constant which we have considered as a minus of P square to decrease the growth of the vibration. Now again substituting the value of this P in G1. Remember you have to substitute the value of the new arbitrary constant in previous solution, not in a G. So we substitute the value of P in G1. We get new solution uxt is equal to C2 sin n pi x by L, C3 cos n pi ct by L plus C4 sin n pi ct by L. Now for the next condition, now taking the initial condition in G2. Now our updated solution is represented by equation G2. Next condition is del u by del t. Del u by del t is equal to 0 at t is equal to 0. That means we have to find out the derivative of G2. So del u by del t is equal to C2 sin n pi x by L, and we have to differentiate with respect to t. Then the inner part is differentiated. We have the constant L upon n pi c. and minus C3 sin n pi ct by L, C4 cos n pi ct by L. Now we have to substitute the value that t is equal to 0. At t is equal to 0, del u by del t is equal to this, and we get the value C2 into L upon n pi c sin n pi x by L into C4 is equal to 0. We know that C2 is multiplied with the complete solution, so C2 is not equal to 0. Sin n pi x by L is never equal to 0. We have only one option. C2 is not equal to 0. Sin n pi x by L is also not equal to 0. So we have only one option, that is C4. So C4 is equal to 0, and our new solution, when we substitute the value of C2, C4 in G2, we have a new solution. Uxt is equal to C2 sin n pi x by L into C3 cos n pi x by L. So the new solution is C2 into C3 sin n pi x by L cos n pi c t by L. Because the physically interpretation of the method is in the expansion of the sine function. Why? Because the model is like this in the direction of x. We can neglect the time, but model will be exist only if point A and B is there. That means the direction x is the important factor. So it is mostly depending upon the sine term. And in a Fourier series, the vibration is always represented by the Fourier series either in a cosine or sine. And if the model is depending upon the sine term, then the constant C2 into C3 is converted into Bn. So finally, the solution is Bn sin n pi x by L and cos n pi ct by L. You have to remember that x is the important factor for the beginning of the model. If we don't have a point A and B, then model does not exist. So it is mostly depending upon sine, not on cos, because cos is a function of t. So it is depending upon the x. So the C2 and C3 is converted into Bn. Bn is the term which is used by the Fourier series. Thank you for watching the video, and for any doubt and any query, feel free to contact your concerned faculty. And stay home, stay safe. For other videos, subscribe the channel. Thank you.